Alright guys, for Module 2 practice on the erosion bottles, we were asked to identify what would be the best land cover for a healthy watershed. In terms of the standards that I chose the next generation science standards where we are evaluating competing design solutions for maintaining biodiversity and ecosystems. So that kind of ties nicely into the imagine part where you're going to create 3 different systems and compare which one had the healthiest watershed. My plan was to make the prototype here. You can see that I used plastic bottles, I used some soil, I had some grass seeds, mulch, plastic cups, and string. So this first visual is what I had outlined, and then the visual above it is what had been cut for the kind of placement of all the mulch. The picture on the right has the one on the left is just pure soil. The one in the middle has soil and some extra grass and some leaves, and the one on the right obviously has the soil and the grass with its roots. So in creating it, the image on the left here is pure soil and it has a dark, very dark murky color. The one in the middle, when poured water on it, it has a little bit less of that murkiness, and then the one here with all the grass is almost pure clear. So the one image here on the right can also kind of help you see the difference between the 3 different cups here. In terms of improving it and modifying it, 2 things popped in my mind. Obviously, the change in slope would affect the amount of runoff. So in general, the steeper and longer a slope is, the faster the water would run off. So there's a potential for more erosion, causing the different colors of water. But ultimately, it's going to come down to vegetation. More roots would cause it to have a clear color because it gets latched on. The big one that I wanted to look at was the soil type, which I kind of took from the water runoff simulation from Module 2. So if it was high infiltration, it meant that there was low runoff potential, and it's typically a sand. If there was very low or very slow infiltration, it meant that there was high runoff potential, and it's usually a clay system. So that's kind of what my backyard has. If you dig it up, it would be more clay-like. In terms of connecting to the chart in our textbook, all right, in terms of science, obviously we had to ask the question of which type of system would best support a healthy watershed. We had to plan and carry out our investigations, so we had to kind of figure out what resources were needed in each case. In engineering, we are again using those models to kind of figure out which would work best. So that's kind of the testing theory part of the engineering design process. In technology, that is using the erosion simulation that I had in Module 2. That really helped me kind of figure out what type of resources would be best fitted for a healthy watershed. And then in terms of mathematics, you kind of had to work through it. You had to test it, and then you would have to improve and modify upon that. So that's part of the solving problem part, and then making your arguments and understanding what type of soil would work best, and kind of just backing that up with some additional research, I think, in this case. But overall, I think it was a fairly straightforward practice. I did like it. I think I would have had a little bit more fun if I would have had the time to grow my own grass in the whole simulation, but I think it worked out pretty well for the most part.